Let's move along to question number 9. All right, so the next question is find the exact length of a curve at y equals x cubed divided by 3 plus 1 over 4x at the interval of 0 and 2. Okay, so let me just write that out here. Y equals x cubed plus over 3 plus 1 over 4x at 1 at this interval. Or we can write it as, okay. So I'm not going to go into the proof of how to find the formula for calculating the length of the curve, but the formula for length of the curve as established by the junior tutor is this. So we call it arc length. And that equal is the definite integral from b to a, interval b a b, of the square root of 1 plus the derivative of fx squared, okay, of dx. So this is the formula for calculating the arc length, okay? It has something to do with calculating, I guess, the area under the curve, but you're calculating very small intervals of it, and that way that you can approximate the length of the curve by doing so. If you want to search up the proof, just search up proof of arc length formula, and you'll find it. Okay. So in this case, the first step that we need to do is we need to find our dy over dx. Okay. So dy over dx is 3x squared divided by 3 plus negative 1 over 4x squared. Okay, which just equals x squared, which just equals x squared minus 1 over 4x squared. Okay, so that's our derivative, dy over dx. Okay, so now we're going to plug that into our integral. Okay, so arc length, let's just call arc length a. Let's call it L, actually. Arc length L would equal to the integral, definite integral of 2, 0 of the square roots of 1 plus x squared minus 1 over 4x squared squared dx. Okay, so we're going to expand this first. So this is just a lot of calculating at this point. So we're going to expand it. So this is 1 plus x to the power of 4 minus 2 over 16x power of 4 plus, no, this should be, sorry. This should be 2 over 16x to the power of 4. It should be 1, I think. Okay, maybe I'll need to really just expand all of it, okay? All right. I'll write it all up. Okay. X squared minus 1 over 4x squared times x squared minus 1 over 4x squared. And this is just all square rooted dx, okay? So let's solve this. This is going to be huge. Okay, so this is going to be 1 plus x to the power of 4 minus, so x squared times this, so minus 2 x squared over 4x squared. plus 1 over 16 x to the power of 4, all under one big square root. This can be simplified to this 1 plus x to the power of 4 minus 1/2 plus 1 over 16 x to the power of 4. Okay, cool. So we end up with this integral after a lot of calculations. Okay. This one can be simplified, so we could write x to the power of 4 plus 1 over 16 x to the power of 4 plus half, all square rooted here, dx. Okay, cool. So yeah, that was a lot. So now we can rewrite this x to the power of 4 plus 1 over 16 x to the power of 4 plus 1 over half as this, okay? X squared x squared plus 1 over 4x squared squared, okay? We can write it alternatively. This can be written as that, and it's just simply like a perfect square, I guess you can say. Okay. And because of that, we can get rid of the square roots because of the square here. So all we're left with, in fact, is integral of x squared plus 1 over 4x squared dx, right? Which equals to 1 over 3x cubed, because we're integrating now. So 2 plus 1 equals 3. Move that exponent down over here. And this is going to be negative 1 over 4x with 2 and 0. Okay, cool. And now we can calculate this definite integral, which is just 8 over 3 minus, where's my x here? My x is here. 1 over 8 minus 1 over 3 minus 1 over 4. Okay? So we're just going to simplify these fractions here. So we get 7 over 3 minus plus 2 over 8, so plus 1 over 8. Okay? And that equals to 56 plus 3, 59 over 24. Okay? So we found our arc length after a long calculation here. So we use our arc length equation. We found our derivative. And then we subbed in everything. We simplified. Then we calculated our definite integral. And then we simplified and reduced all our fractions until we got 59 over 24. And now we know that the curve of x cubed over 3 plus 1 over 4x at the interval 0, 2 has arc length of 59 over 24, or a junior tutor wrote out the decimals, which is 2.458. Yeah, so that's just units, and that's how you calculate arc length. Okay. And again, if you want to find the proof for how to find the formula for the arc length, just search it up online, and they'll go through step by step the theory and the thinking behind how to find the formula for arc length. Okay.